Stream starten. 1, 2, 3. Yes, sir. Oh, really? Live on YouTube. Yeah. Yes, we have to stop this one, right? Look at the stream health. And look at another one. And this one. We are going to close it like that. Yes. And this one too, right? Submitting. What's the line? This is go to the manage. Okay, go to manage. Yes, sir. In add the description. And offline. This one. No. Stream free network. And 20. Ui. Yes. 20. Go to the chat. And yes, take a look at this is zoom, right? Zoom. What is it? Yes, here's the in to close it. In yes, in this one, right? And yes, to do. Hey. Yes, in fresh done. Yes, sir. Yes. In yeah. The this one you're gonna need to change the title, right? Session, right? Yeah. Resting. No. This one. And yes. Copy it. And yeah. So tone A, tone V. Fetish. Yeah. Someone is coming. Right. Yes, Streamlab. Turn on the microphone. Oh yeah. Right. Okay. Yes. To close the microphone here and take a look at this. Hello, test. Okay. New person, right? Timing. yes sir มีใครจะเข้าอีกไหมครับมาแล้วไปแล้วนะนภัส and who else nothing alright yep and okay so we'll show right in Thailand okay this one right and yeah it's the M604 right ปิดไว้ก่อนพวกนี้ปิดไว้ก่อนทั้งหมดyes sir solid liquid right this one yes sir we live at this one and Petra okay all right yes good morning everybody welcome you back to the SCI33206 we are live at the topic of fluid pressure and buoyant force right what you can see here is the different kinds of fluids right you know that fluids include both liquid and gas right so but this one we are going to talk mainly about the liquid so in liquids there are as you know there are so many types of liquids and yeah once they stay together we try to keep them in the same container like this so they would not be mixed themselves together they try to stay separately okay it depends on the density right to each one and paste okay and yeah we will see the first property which is the density right density is measure I hope that the sound is okay right density is the measure of the amount of matter per unit volume and yeah and the density is the mass divided by volume simply speaking and we use usually the Greek letter rho right rho rho to denote the density and what else nothing more right and yeah we use the Greek letter rho rho to denote the density and if the mass m of material has a volume v so from this definition we are gonna have rho equal to m divided by v. And as you know, in physics, the unit is also important. And let's get into the detail. Maybe you have seen this stuff already. The unit of the mass is the unit of the mass is kilogram, right, in the SI system. And the unit of the volume is cubic meter. So the unit SI unit of the rho or the density is kilogram per cubic meter. All right. And yeah, density also depend on temperature and pressure. So yeah, if it depends on the way atoms stack together in solid. Yeah, if it's tightly stacked, so we have more molecule or more mass in a certain volume, and we would have a greater or higher density, right? For some elements have many allotropes or form, okay, in chemical or in physics. In our story, we would say allotropes. For example, graphite and diamond are both solid form of pure carbon, and yeah, they are both made of carbon, but they have different structures. So yeah, they have different densities too, right, and other properties. Yeah. What else? Gases are less dense than liquids. That's typically right in which are less than solids. Yeah, it would have less density than solids. And however, there are many exceptions. For example, ice, which is a kind of solid, like of water, is less dense than water. Okay, in this case, the solid may have less density than the liquid form, right? And a few gases are heavier than liquids. For example, water is lighter than tungsten hexafluoride gas. All right. I don't know whether you have ever heard the tungsten hexafluoride. Yeah, it's a special kind of gas. Okay, it has more density than the water. For example, water is a liquid. So there are many exceptions. Okay, you may not. Yeah, if you want to do the pass some exam, entrance exam to some university, you may have to remember this. But in real life situation, we wouldn't use it. Okay, except that you work in a chemical company or spatial company like that. Okay, hydrogen is the lightest or least dense element of the periodic table. All right, in yeah, what else? The densest. Okay, if we talk about the lowest one, right? The highest one is that the densest material found on Earth. Okay, let's talk about the stuff on Earth. We didn't talk about the stuff outside our planet. The densest material found on Earth is the metal osmium, which has 20,000, right? 22,500 kilogram per cubic meter. Okay, which is really very dense. Okay, and if we talk about the substance or the object outside our world, it would be the white dwarf star. White dwarf star is on the order 10 with the power of 10. All right. In neutron star. Okay, and that of neutron star. Okay, I hope I guess that this would be the star that's has only neutron, right? The astronomist would have some ways to predict or to observe the star that contains only neutrons. Okay, and in that star, they predicted that the density is on the order of 10 raised to 18, right? Which is very, very high. Okay, this one is around 2 times 10 raised to 4, right? But this one is 18. Okay, the power of 18, which is very, very dense. All right, and what else? Okay, let's get into the material on Earth. We have, for example, ice, right, which is less than water. Water is usually the water usually has 1,000 kilogram per cubic meter, right? But this one is less than that. It's less than 1. All right. Yeah, water is right here. These are all in solid form, right? In what else? These are all in solid form. But this one, this column provide the density for liquid form and gas form, right? This fluid. This one is the column for fluid. This column is given for the solid, right? Okay, if you take a look at heavy metal, for example, copper, silver, lead, gold, platinum, okay, they are all on the order of 10 raised to 4, right? But these one, okay, mercury even is a solid form, right? Is in a liquid form. It has its own density quite close to that to those in solid form. Okay, this is an exceptional case. All right. What else? I think nothing more, right? The one here is air, right? It is spatial, right? It's on the order less than 1,000. Okay, it's on the order of 1 only. For example, the air has the density of 1.29. Okay, and oxygen. Okay, air contains also nitrogen and other stuff, right? It would have less density because it contains some contamination. All right. Yeah, we have to accept that. That's nature, right? We couldn't do anything. The oxygen has even greater density than higher density than the air. Hydrogen is even less dense than the air. Okay, it's only that's the least dense. Okay, the lightest, the least dense element, right? Hydrogen, and helium is another kind of gas. Okay, it's inert gas, and it's on the order 0.1 1.8, right? Kilogram per cubic meter. But note that the value on this table are at standard atmospheric temperature and pressure. It's denoted by HTP, okay, and defined as 0 degree Celsius and 1 atm. 1 atm means 1 atmospheric pressure, all right, and yeah. Together with 0 degrees Celsius and 1 atm, we are gonna call it is said to be standard atmospheric temperature and pressure, STP. Okay, and one important thing, the so-called 1 atm is equivalent in the SI system to 1.013 10 raised to 5, okay, Pascal. And if you want to convert it to a smaller scale, like in chemistry and other subjects like that, if you want to be if you want to work in nutrition, okay, you may have to convert those quantity into a smaller scale, and it's called CGS, right? Smaller scale, smaller unit scale. And if you want to convert them to this smaller scale, you have to say you have to multiply it by 1 10 raised to negative 3, which is equivalent to the division by 1000, right? Okay, and this one is from, oh sorry for that, there is sound, sorry. Okay, we would see the another table which also talks about density. It is taken from another book, okay, the book number 2, and yeah, the value is quite close to each other. Gases, right? It's 1.2. Okay, this is air, right? It's air. They in this book they say 1.29, but both are quite close to each other. In for the liquid form, we have benzene, ethanol, water, benzene, ethanol, water, seawater also here, right? Please note that seawater is more dense, okay, than the normal water, the pure water, because we have also sodium chloride, right? And the blood inside our body is even more dense than seawater. Glycerin is another kind of it's in solid form, right? 1.26, and ice is a kind of solid. It's less dense than water, as we have seen. You can see ice is 0.97 and 0.92. Okay, both are quite close to each other. And here is a heavy stuff, aluminum, right? Heavy metal like iron, brass, copper, silver, lead, gold, platinum. Those are heavy metal, and even you faced with the rare earth material like gold or platinum, they are really dense, okay, like 19 and 21, but their price is also quite high, okay. Let's talk about the stuff outside our earth, our world. The first one is white dwarf star, which is 10 on the order of 10 with the power of 10, and neutron star, it's on the order of 10 raised to negative 19. Yeah, to obtain the density, you have to divide by 1000. Okay, that's the first basic term, right? You have seen ตะกี้มีไลน์นะครับ มีไลน์คนหนึ่งไม่รู้ห้องนี้หรือเปล่า ถามว่า อ่า แก้กันบ้านได้หรือเปล่านะ คือคุณว่าไงดีผมให้คุณถามตัดสินใจกันโอเคไหมครับ ของปอตีผมให้แก้นะ ก็คือ075บางคนคิดเลขผิดอ่อนกว่าคุณอีกโอเคไหมเรียนอยู่วิศวะได้ยังไงปริญญาตรีนะครับกดเครื่องเลขกดไม่เป็นนะครับทศนิยมก็ผิดถูกนะครับ เอาเป็นว่า ผมเห็นใจสงสารนะ แต่ว่ามันเพิ่มภาระผมนะครับ เพราะว่างานชิ้นหนึ่งบางทีก็ตรวจกัน3 รอบ 4 รอบบ้างครับ คุณแบบสเปะสปะหรือว่าไม่คิดอย่างรอบคอบนะครับ คุณก็สักแต่ว่าส่งมานะ ไม่ได้ตรวจทานแก้ไขอย่างเดียวก็ผิดอยู่งั้นนะครับเป็นการเพิ่มภาระผมนะครับ ใช่ไหมเดี๋ยวขอดูที่ไลน์กลุ่มก่อนพวกที่อยู่ใน YouTube นะครับ หรือว่าเข้ามาในซูมแล้วออกไปเข้ามาพิมพ์ชื่อแล้วออกไปก็ตามนะ ผมฟังเสียงคุณนะคุณจะรับว่าแก้ได้ หรือไม่ให้แก้ครับพิมพ์ตอบมาครับเอาแฟร์นะครับ604ว่าอย่างไร605ก็ว่าไปตามนั้น เพราะคุณน่าจะเลือกก่อนมีสิทธิ์ก่อนแล้วกันเนาะright 604นี่604นะคุณนะครับคุณบอกว่าแก้ได้ไหมครับ แล้วก็แอดชื่อผมมาให้ผมตอบเพื่อนว่าอย่างไรครับเพื่อนคุณอยู่กันไหมเนี่ยอยู่ที่ YouTube 2 คนทั้ง2อย่างละ2 ช่องนะแล้วก็ที่ซูมคุณอยู่กันไหมเนี่ย alright are you there ไม่มีใครอยู่นะที่ซูมนะครับซูมไม่มีใครเข้ามานะก็คุณจะยอมรับให้เขาแก้ได้หรือไม่ให้เขาแก้ครับ What do you think whether you would accept that your colleagues your classmates can edit their homeworks or not รุ่นพี่คุณอะไรเขาก็ไม่มีคุณนี่แบบสบายสุดแล้วนะครับการบ้านก็ไม่เยอะนะครับการบ้านอาทิตย์ละชิ้นแค่นั้นเองรุ่นพี่คุณอะอาทิตย์ละ2นะเรียนครั้งหนึ่งโหผมก็ตรวจเหนื่อยครับอันนี้คุณคุณทำเหมือนกันนะคุณลอกไม่รู้ลอกกันหรือเปล่าไม่อยากสบประมาทแต่ว่ามันเหมือนกันเดะผิดเหมือนกันเดะคนอยู่ที่ YouTube ครับคุณจะยอมให้เพื่อนเขาแก้งานได้ไหมคุณพิมพ์มาครับนะตอบมานะว่าให้เพื่อนพิมพ์งานให้มันเสียเวลาเรียนต่อดีกว่าโอเคfind the mass of the air and its weight in a living room with the dimension of 4 times 5 floor and the ceiling is of the height 3 meter what would be that's the first question right the mass of the air and what would be the mass and weight of an equal volume of water okay we are gonna need the same dimension right which is this one they have provided here 3 times 5 4 right that's the shape of cubic okay that's the shape of cubic and whether you what do you think whether you would this one ผมแชร์ไปแล้วหรือยังหน้าจอ let me check whether I have shared it let me check whether yeah it's still sharing right it's still in sharing okay yeah the first question is to find the weight mass, right, of the air, and the second situation is that we will fill this room with we're gonna fill this room with water, right? So yeah, first we have to recall the formula of the formula of we're gonna recall the formula of density, right, which is rho equal, oh, sorry for that, rho is m by v, right? And as we want to find m, so we are gonna have m equal rho v and w, which is the weight, right? It's equal to mg, okay, the gravitational acceleration on Earth, right? Yeah, for the first case, for the air, right, we are gonna compute. Let's talk about the air. Okay, this is the air case, and m air will be equal to rho of air and the volume of the room, right? The V room. Okay. As we know, sorry. As you know before, rho air is available in the table, right? It's I don't know this one what they want to use. 1.2. Okay, they use the last table under the last table, which is this one, right? 1.2 kilogram per cubic meter. 1.2 kilogram per cubic meter, and the volume of the room will be its width and length and height, right? The multiplication of these three terms, width times length times height, right? And yeah, you would have with this 5, right? 5 length is 4 and the height is 3, right? We're gonna have 60 cubic meter, right? Like that, and that's the volume. And if you substitute this formula and this one to this expression, you're gonna have m air will be 1.2 times 60, and it's gonna be 72 kilogram, right? And now we are gonna convert the mass to the weight, right? And as we know, weight is mass of that object times the gravitational acceleration on Earth is 7 and 9.8, or you say sometime 9.81, okay? And yeah, you just put it into the calculator. You're gonna have 705 0.6, right? And the unit for the force or the weight is Newton, right? Here who is in so okay okay, let's check only one person. It's นภัสนะครับนภัสเข้ามาคนแรก it's only the part in yeah, let me send it to you so thatนะครับคุณอย่าลืมกติกานะครับตั้งแต่เทอมที่แล้วนะผมบอกไปแล้วว่าการบ้านอย่าลอกกันเนาะไม่รู้จำได้หรือเปล่าการบ้านก็คืออย่าพยายามทำให้เหมือนกันนะครับมันสุ่มเสี่ยงนะโอเคplease try to change some details in that problem so that they're not going to be the same or replicated the replica to your colleagues. All right, don't use the same problem, or even you want to use the same one, you have to change the number somehow. All right, and yeah, let's get into the detail for the case of the water in this one, right? For the water, we're gonna use the same thing, which is mass of water. Mass of water will be rho of water times the volume of the room, and yes, of course, rho of water is the density of water, right? It's right here, which is 1000, right? Let's say it's pure water, so this one is 1000, right? Times 72, right? No, 60 cubic meter, you're gonna have 60,000, right? Kilogram, okay, which is very, very dense, and the weight of the water, the weight of the water could be easily found from m of water times g, right? And you have 60,000 times 9.8, right? And once you put it into the calculator, right, it's gonna be less than that. It's 5880. And it's Newton, right? ขออนุญาตนอกเรื่องนะครับเหมือนว่าโรงเรียนเขามีกำหนดการนะครับที่จะให้เรานั้นไปเรียนที่ห้องเรียนจริงครับก็5 กับ 21 ลาครับงานโรงเรียนโอเค no problem นะครับก็หวังว่าคุณคือผมไม่บังคับนะเป็นสิทธิ์ของคุณเพราะว่าคุณก็เป็นทรัพย์สมบัติของคุณพ่อคุณแม่คุณเขาเลี้ยงดูคุณมานะครับบางทีคุณพ่อคุณแม่คุณเขาอาจจะไม่อยากให้คุณมาก็ได้นะผมไม่ได้บังคับนะครับใครจะมาก็ได้ไม่มาก็ได้แต่ว่าผมเป็นคนโตคนผู้ใหญ่ครับผมก็ต้องรับผิดชอบนะครับถึงอยากไปไม่อยากไปผมก็ต้องนะครับก็ต้องไปนะก็หวังว่าคุณฉีดวัคซีนกันแล้วนะเพราะเขาลงให้ไวอย่างคุณฉีดกันได้แล้วครับก็รักษาเนื้อรักษาตัวนะครับก็ขึ้นกับคุณตัดสินใจนะเผื่อบางคนยังไม่ทราบข้อมูลครับ alright so we gonna go ahead with the next stuff the pressure, right? We need to introduce somehow the density, which is the common term, which is the typical term, and yeah, it's very normal, right? This term, yeah. The pressure P, is defined as actually pressure has to be introduced before in the chapter of heat and gas, right? But we will talk about it again. Assume that you have never seen that the definition of pressure before. Pressure P on a plane surface. Okay, let's talk about a surface that is planar, and that plane has the area of letter A is the magnitude F with perpendicular subscript here, the perpendicular subscript of the force divided by the area. Okay, let's say it's you have an area A here, right? And you have the force, right, exerted on this area uniformly. Okay, everywhere has the same magnitude. And this one is F perpendicular. And you're going to have pressure, which is the ratio between the force, okay, exerted on that area, divided by the amount of that area. Okay, let's see. This force should be perpendicular to the plane of this area. Okay, the SI unit of the pressure, as you know, it's Pascal, right? It's in SI unit, it's gonna be called Newton per square meter. All right, this unit is given by a special person, which is called Pascal, denoted by PA. The atmosphere is the layers of air wrapped around the Earth, and the air has a weight and pressure against everything it touches. Okay, whether you are tree, you are building, you are animals. Okay, the pressure will act on you. Okay, uniformly. Okay, it doesn't. The pressure doesn't care what type you are, and the air works due to the gravitational force. Okay, the gravity pulls the air to you. Okay, to pulls the air to the Earth. A barometer is an instrument used to measure the atmospheric pressure. And it's also known somehow barometric pressure. Okay, barometric pressure. This pressure varies with weather changes and with elevation. Okay, I think N is nothing. อันนี้ผิดเดี๋ยวตัดทิ้งครับ and if you don't understand, take a look at this. Okay, this is the almost the spherical shape, right? It's spheroid, right? Because this side is greater than the side between the North Pole and the South Pole. Due to the rotation, right, as you have seen in the previous semester, the Earth rotates around itself, and the water on the sea, on the ocean, just has the centrifugal force, right? So it makes the shape from the perfect spherical shape to be spheroid, right? That's the reason. And if we stay on Earth, like in this area, and if we measure or build up or consider only the cubic, okay, let's say it's a square area here, and we build up a height like this. Okay, column on air above us being pulled by gravity. Okay, the of course air has its own molecules or atoms, and Earth is a big object, and an object and another object would have their own attractive force, right? And that attractive force acts to us as the gravitational force. Okay, the air is pulled down by gravitational force, the attractive force between the air molecule and the Earth molecule. And atmospheric pressure happens to us like this. And if we take a look at the barometer, this type is called Anaeroid Barometer. This figure is taken from a website in internet. I forgot to mention the source of this figure. contains a sealed box that expands or contracts, okay, or shrinks with the pressure, resulting in pulling or pushing a spring to move the pointer or the needle up and down, right? And yeah, it's gonna show you. Okay, there are also symbols like sunny day, cloudy day, and rainy day or something like that. Okay, nowadays that type of Aneroid barometer is no longer in use. In modern system, I think even more modern than this, we have the so-called digital barometers. Okay, it gives you more precise results. Okay, in pressure measurement, they display it clearly. Okay, you don't have to get confused to several bars here on the circular scale of the Aneroid barometer. You just simply realize the number that is illustrated on the monitor of that digital barometer. Okay, it's very, very, very clear. It's the same thing as in electric measurement device. Okay, the multimeter is now in the digital form. Okay, you just take a look at the numbers only, and you can easily realize that. And nowadays, the precision of digital device is better than those in the previous generation. Okay, and barometer has no exception. The newly modern design of barometer is in the digital form like this. Okay, atmospheric pressure (PATM) is denoted by P with subscript ATM. Okay, please note that it's not automatic telling machine. Okay, teller machine, which is the machine you withdraw the money. It's different. This is the atmospheric pressure. Okay, atmospheric is denoted by ATM. The pressure on Earth atmosphere, or the pressure of the Earth at the sea level, is this value. Okay, is denoted by atmospheric pressure. But if you go to the apex of Himalaya mountain, okay, you will not have this atmospheric pressure because you are really, really high above the sea level. Okay, your pressure is gonna be lower than that. Or if you consider the pressure at the plane level, the airplane level, okay, because you are really higher than the ground or the floor on Earth, you would have less pressure, okay, than that for the people on Earth, on the ground, on the floor. Okay, the average atmospheric pressure at the sea level is measured at 15 degrees Celsius, and is used as the unit of pressure. It's called atmospheric pressure. And yeah, because pressure is the basic quantity, it's used in several societies in science, and in each society they would prefer their own easily called scale, and it's called for example Pascal, right? Pascal is the SI system. 1 ATM is approximately 1.01325. Okay, you just use only 1.01, it's fine. Okay, but don't be so love to use only 1 time Taylor's to the power let's just 25 Pascal or Newton per square meter, right? The unit of that. And we would also say 100,000 Newton per square meter is equivalent to 1 bar, right? 1 ATM is not, okay, I would say is not 1 bar. Okay, ATM is not directly equivalent to bar. 1 ATM is approximately 1.01325. Okay, the same number here in front of those in Pascal unit. And if you, in some situation, they would call millibar. Okay, they want to observe the pressure in millibar, and the 1 atm is equivalent to 1000 because you have to multiply this one by 1000 and the units reduced by 1000, which is milli. Okay, 1013.25 millibar. And for those for the people in the United Kingdom, okay, or in Great Britain, they would use their own unit system, right? It's called power per square inch. Okay, power per square inch is the unit for the British system, and you may hear this one in if you work in a company in London, in England, and so on. Okay, and 1 ATM is equivalent to 14.696 power per square inch มีใครพิมพ์ชื่อมาใหม่ครับไม่มีนะ and for the people measure with respect to the mercury level is gonna be equal to 760 millimeter mercury. And for the people in Great Britain, if they want to measure the pressure in relation to the mercury, it's going to be equal to almost 30, okay, 29.9212 inches mercury. Okay, you may see that pressure has various form, various units. It depends on which society you're going to work with. But for you at the high school level, we start from the SI system, Pascal. And if you go to the bachelor degree, if you are really interested in physics or in special kind of science, okay, you may encounter these spatial units. Okay, Pascal is used worldwide. As I told you, you can work it everywhere if you understand Newton per square meter or Pascal. Millibar or hectopascal is used by meteorologists. Okay, the people who deal with weather forecast and weather prediction and so on. Inches mercury is used in the United States. Okay, not only in Great Britain. Also in the United States, in the Barometric Formula is given by this one. Okay, if you are higher than the typical sea level and you want to find the relation of your pressure when you don't have the barometric, when you don't have Aneroid barometer, you can also use this formula to predict the pressure at your level. It's equal to it's made with respect to PATM. Okay, you need to know first this value, the pressure at 1 ATM in whatever unit. Okay, just use it, and that's the value of PATM. And this is the exponential function, you know, right? Exponential function with the power of when this one has the exponent of negative, it means exponential appear here as the denominator. And if you are higher, okay, your h is greater, this one has more division, right? A denominator, and the whole value is gonna decrease, okay, or reduce. So if you go higher from the sea level, let me open another good notes. All right. If you go higher, yeah, above the sea level, okay, you go higher, you will have less pressure. Okay, you will have less pressure if you go higher from this column. All right, and yeah, if you stay on the planet that has more gravitational acceleration, you would have also less, right? Less pressure. And what about the relationship to temperature? If your temperature increases, you're gonna have more pressure, okay, because this is the division term. All right, yeah, K is the Boltzmann constant, which is equal to ideal gas constant divided by Avogadro number, right? You know Avogadro number. It's gonna be introduced later. T is the temperature in Kelvin. Okay, you cannot substitute the value of the temperature in degrees Celsius. Okay, you have to add it by 273. What else? M is the mass of that molecule, of the air molecule. Yeah, let's get into the first example about the atmospheric pressure in the loom described in the previous example. Like in this example here, we have 5 meters of width, the length of 4 meters, the height of 3 meters. Yeah, in that example, we're gonna consider what is the total force on the floor due to the air above the surface if the air pressure is 1 atm. So how could we do that? Okay, that's the first example. Here's the second example. Okay, no problem. Yeah, for this example, they just asked about they just asked us about the pressure on the floor, right? Okay, that's the floor. The floor is gonna be here, right? Okay, let's draw it again. That's the lecture note for the M605. Okay, we draw it for us in this way. And the floor, of course, the floor is the lower side, right? And yeah, floor is right here, right? And of course, the area of the floor is what we need to determine, and it's gonna be width times height. Oh no, times length. The length of that room, and you would have 5 times 4, right? And it's equal to 20 square meter, right? Okay, and that's the thing we need to know first. Okay, and they say the pressure here that take place, okay, pressure, and they want to know F, right? They want to know F. What is F in this situation, right? F is F perpendicular, and the pressure here, they say P equal P ATM, right? Oh, P ATM, right? The atmospheric pressure to this room. And of course, from our definition, the pressure is F perpendicular by A, right? And we are going to transform this expression for the force only, F perpendicular with the subscript of perpendicular, It's gonna be the multiplication of pressure and air and the air, right? The area, sorry, and the pressure, which is pressure at atmospheric times the area of the room, right? Area of the room, area of the floor. And you would have ATM, right? It's, yeah, as we know before. One ATM is this one, right? If you want to compute it in the SI system, we're going to use 1.01325 times 10 to the power of 5. And the area is 20 square meter. And of course, you put it into the calculator, right? You're going to get 2.0265 times 10 to 6. And here is Newton, right? Yeah, all of this is the result, right, for the perpendicular pressure force. And yeah, what time is right now? 9:33. Right? We're gonna leave our lecture at what is that? เราต้องจบที่เท่าไหร่8:30 and 10:10, right? So we're gonna 9:50, right? We have still more 17 minutes. All right. Yeah. The next problem is this one, right? What happened? In figure 36, this figure, we have downward force is caused by air pressure, right? The air pressure is gonna push every object, not only this one, right, but also the whole water or liquid here. There is upward force, okay, is caused by the pressure of the water and must equal the weight plus the downward force, okay. This is the weight of the water in this area, okay, in this volume, plus the downward force of the air pressure, okay. There are two force by air, weight of this water column, and the force upward. Calculate the weight of a cylindrical column of water with the height of 40 meter. Okay, the height here is 40 meter. H. The letter H is of 40 meter. And the radius, this is the cross-sectional view of cylinder. Okay, the front cross-sectional view, front view of the cylinder. Okay, you cut like the Coca-Cola can and you see the rectangle shape like this. Radius is 1 meter. Okay, you can see that it's if the volume of cylinder, right? It's, we say there is gonna be, what is that? It's gonna be pi r square h, right? The cross-sectional area times the depth, which is the height here of the water. Okay, that's the volume of cylinder. Calculate the force, the weight first. Force exerted by the air on a distance of radius 1 meter. Okay, here we need to know the force down. And what pressure at the depth of 40 meter, okay, supports the water column. Okay, there are three main questions in this problem. Okay, let's go ahead with that. Yeah. The weight of the cylindrical column of water, right? So if we have the pure can or pure cylinder like this, and we fill the water in. We pour the water into this, okay, water, and we fill it until it full. Until the can or the cylinder here is full of water, we get weight, right? They want to know weight of the water, right? So the weight of water is gonna be mass of water times g, right? The acceleration on Earth, and we know that the mass of water is rho water times v, right? Mass is density is mass divided by volume, and we move volume to the right hand side. Volume of what? Volume of cylinder. Okay, because we consider only the shape of cylinder. Water inside cylinder. So yeah. And what is V cylinder? V cylinder is, as we know here, pi r square h. Pi r square h. And we substitute both expression into this one, right? We're gonna have W weight water will be equal to best, right, which is the rho water, and times pi r square h times g. All right, many variable, but it's not too difficult. Rho of water, of course, this is the pure water or seawater. They say only simply water, right? So oh my god, no, not this one. We're gonna use the pure water density, which is 1000 10 raised to 3, and pi, right? Pi, and r square. R is the radius of this one, which is known here. Okay, r equal 1, right? R equal to 1. So this is the 1 with the power of 2, and the height is 40 meter, and g is the acceleration of 9.8, right? You put it into the calculator, and you would get the excellent number. It's 1.23, okay, approximately Newton. That's the weight of the water in this shape, okay, the cylindrical shape. The second question is calculate the force exerted on the air by the air on a disk of radius 1 meter. Okay, we consider the lid, the upper lid of this can, of this cylinder. We would have here a disk, right? Radius here is 1 meter, right? The radius is 1 meter, and the force exerted on this, right? The attractive force of the gas, the air molecule to the water molecule, right? And here is F perpendicular, right? According to the definition of the pressure, right? And as you know, pressure is F perpendicular by A. So this one is here. Here we need to determine the area of circle, right? Air on a disk, okay? A disk A disk, it's a circle, right? So area is equal to area of circle, which is pi square, right? And F perpendicular, oh, F perpendicular will be equal to, pressure is F by A. So if you want to find F, you have to move A to the pressure, right? Pressure times A disk, okay, A disk, P, the pressure is PATM, right? We need to write down also here the detail PATM because we observe this at the atmospheric temperature, atmospheric pressure. So PATM, what is that? PATM is 1 point here 0.01325 times 10 with the power 5, and A disk is pi r is number 1 square, right? You put it into the calculator, you're gonna have F air, which is 3.1832 many times 10 to 5, and the unit for this is Newton, right? It's quite heavy. Okay, the next thing is that what pressure at the depth of 40 meters to support the water column. And as you know, we need to sketch the free body diagram, right, of an object. Okay, this is the water, this is the front cross-sectional view. Of course, this is the force exerted by the air, right? And there is the weight. Center mass of this object has the weight, right? Weight of water. And of course, under this can, under this cylinder, there should be a force upward, right? Upward force, which is called F up. Okay, F up. And from the first law by Newton, เป็นไรเนี่ยเจ๊งครับ sorry for that. There is an internet connection problem too for me. Oh, I have to use this one, right? I should not use this one. Okay, okay. First time. Yeah. Let me check the internet connection. We have to use this one, T3, right? T3 technology. ลืมเช็คอินเทอร์เน็ตครับ all right yeah, okay, let me share the screen again มีปัญหาอินเทอร์เน็ต but trying started. Okay, all right, I hope everything is fine. We almost complete this problem. Yeah, from the first Newton's law, right? We gonna have sigma F remain 0, right? And yeah, let's say positive mean pointing upward is positive. Everything is pointing up is gonna be considered as something positive, right? So F perpendicular is pointing down. So we're gonna have minus F down or F perpendicular. Oh my god. F perpendicular and downward force of water, weight of water, and upward force here, F up. Okay, equal to 0. And we're going to solve this equation for F up because we know F perpendicular and the weight of the water right here, right? Perpendicular force is known, or weight of the water is also known already. So we would have F up equals F perpendicular plus the weight of water. But they don't want to know the force at all. They want to know the pressure here. What is the pressure at the depth of 40 meters support the water column? And as you know, under this can or this cylinder, the area would be the same, right? Because it's the perfect cylinders. The area in the upper lid would be the same as the area at the lower lid, right? And we have already calculated, which is the pi r square, right? This is pi r square. So according to the definition of the pressure, let me check.ควัตมาใหม่มาเก่าเนี่ยพิมพ์ชื่อคนท้ายนะผมรับพิษมีแล้วใช่ไหมรับพิษมีแล้วควัตไปแล้วโอเคในหน้ามีขายพิษเพิ่มนะครับ yeah according to the definition of the pressure is F divided by A, right? And yeah, P at 40 meter, right, will be F up divided by area of disk. Okay, the lower lid of this will be the same as the A disk. F up is what? F up is F perpendicular plus W of water and divided by the area of this, which is pi, what is pi r square, right? Okay, we're gonna substitute everything, and the first quantity is 1.23. The nice number 1.23 times 10 with the power of 6 Newton, right? Oh no, yeah. And F up, that's the weight of water. F up is yeah. I'm stupid. F up is just found here 3.18. 3.18 times 10 raised to 5 and plus 1.23 times 10 raised to 6, right, which is this value here, right? 1.23 to the power of 6 and divide it by the area, cross-sectional area, the lower it reaches pi r square, and r is the radius of 1, right? So 1 square, and we would have here after you put it into again the calculator, we would get 493.325 Newton per square meter. That's in the SI system, but if you wanna express it in the understandable unit, we would say 3.93325 times 10 with the power of 5, and it's actually Pascal, right? It's 0.5 megapascal actually. You can't say that. Okay, 0.5 megapascal, and yeah, that's the thing for today, okay, it's 9:52 already and ผมต้องชดเชยไหมเพราะว่ากว่าจะเซตเวลาอะไรมันช้าต้องชดเชยไหมใครที่อยู่ที่ YouTube เวลามันเลยไปแล้วกว่าจะเซตเครื่องนะ604มันเสียเวลา10 นาทีอะไรอย่างเงี้ยก็จะเอายังไงครับให้ผมต่อไหมหรือว่าต่อสัก10 นาทีไหมหรือว่าชดเชยเลิกเลยต่อแล้วกันเนาะเพราะว่า604นั้นเสียเวลาเซตเครื่องประมาณ10 นาทีโอเค fluid would flow from the higher pressure region to the lower pressure region okay that's a typical thing when a fluid is at rest in a container all portions of the fluid must be in static equilibrium okay and at least with respect to the observer okay it doesn't move at all parts at the same depth must be at the same pressure that's the basic thing you need to know when you deal with the pressure of something pressure of fluid okay let's take a look at this figure you have a container here you leave the like water or a kind of fluid in a static fluid you know that if you study engineering there will be subject at the beginning at the first year you would have static dynamic okay something like that that's the first those are two first subjects in engineering okay in static fluid the force F1 must be equal to F2 okay if both are not equal to each other this water should move somehow okay because there is F remaining there is force remaining okay and the force on top of a considered volume we call P1A okay at the upper side should have some relation to the force in the downside pointing upward and this one is mg the weight of the water like the cylinder you have calculated in the previous example and if the height between these two bar is y1 and y2 right you have y1 and y2 the height is going to be y2 minus y1 right or y1 minus y2 the distance between these two y's and that's the height and yeah the force is mg right the weight of this water and pressure 2 and pressure 1 would have some relation that's the figure taken from the book number 1 and here is the same thing which is taken from the book number 2 upward force is pa the downward the downward force at the upper side is pa upward force at the lower side is p0a and there is the weight of this object and the height is h okay height 0 is the reference level here okay height equal to 0 is the reference level and we call pressure is p0 force due to pressure on top of surface and this is the weight of the volume element whether it's water or any kind of fluid P0A is the force pointing upwards due to the pressure P0 on the bottom surface. Because the fluid is in equilibrium, these three forces would follow the first law of Newton, right? The first law by Newton, and the vector sum of vertical forces on the volume must be 0, must remain 0. Yeah, we get this one, okay? Pointing up is positive, pointing down is negative. So we have two terms of negative, PA and W. We have only one single term of pointing upward, which is P0A. All right. Let's examine the fluid contained within the volume indicated by the darker region in figure 38 and 39. Okay, in the darker region, this one. Okay, darker region. Let A be a cross-sectional area that extends from the position y1 to y2. Okay, from y1 to y2. Below the surface of the liquid. Three external forces act on this volume of fluid, such as the downward force P1A, exerted by the fluid above, and the force of gravity mg, the upward force P2A upward, okay, exerted by the liquid below. Newton's first law in the form of summation of M remaining zero leads to this one, okay, which is the same thing here we could find, okay. P1A in this figure, okay, minus P2A and minus, hey, is that correct? I don't think it's correct. MT is downward. It should be negative. P2A is pointing up. No, this one is incorrect. I'm gonna change it later. P1A is pointing down. It should be negative. This one is positive, right? P2A is pointing up, right? And yeah, based on this density relation, we can derive M based on the density, right? M is low V, and yeah, mass here is M and G, right? M is rho V, sorry. Delta V is y1 minus y2. You substitute it into this expression, and you have M, right? Low A y1 minus y2, and you have minus P2. Okay. I don't understand why they say plus. This is minus. Okay, and P1 minus P2 and minus low AY1 minus Y2. Right. Yeah. And low Y1 minus Y2 G equals 0. And we move everything to the right hand side. We're going to have P1 is equal to P2 rho G Y1 Y2. Oh, this is incorrect. It should be P2. No, not this one. It's going to be minus PA P1A plus P2A minus MG equals 0. And yeah, when A is not 0, we can cancel A everywhere, right? We can cancel A everywhere. And yeah, but this one is the rho A y1 minus y2, right? And times C, right? We can also cancel A, and we would get minus P1 plus P2 and minus rho y1 minus y2 and G, right? And equals 0, right? And you can see that if you move the negative term to the right hand side, P2 will be P1 and plus rho y1 minus y2 and G. All right, this is the correct way. This one is incorrect. I'm gonna change it later. Yeah, and fluid with density here, right? And we would say the P0 is P ATM plus rho GH, rho G, and Y1 minus Y2 is H, the difference, right? Yeah, the pressure at a depth H in liquid denoted by P0 is greater than the surface pressure P ATM. Okay, H is Y1 minus Y2. So we get finally P is P0 plus low GH. Okay, and if P0 is ATM, we're gonna have that also. Okay, we have to stop or quit the lecture right now because we are running out of time. See you on Wednesday, and the homework is to find is the problem related to, you need to find a problem related to density and pressure. Okay, the problem about density and pressure, and we will see it later. Okay, all right. 3 people in the OBS channel. Okay, now we will leave the class. See you on Wednesday. If you have any question, just let me know. Okay, if not, then bye bye สวัสดีครับบ๊ายบายครับกาซิดิตเพิ่งมา oh not this one right we have to send กาซิดิตเพิ่งเข้ามาพิมพ์ไม่มีกันครับไม่มีใครพิมพ์แล้วนะ เฮ้ยbased on the density relation Newton's first law plus P plus you would have minus PA plus P2A plus minus and we're gonna have P2 P1 plus this one yes หน้า90โอเค90 it like this instability. I to copy this one. Right. Don't include this. Document. Lecture. Oh. So. Assets. And this one. Right. Pot here. It's solid liquid. And that's in, we would say, solid here. It's hop. And this one we're gonna call M. Enter. Yes. This one. All right. Okay. Still here. No one is coming. All right. This you should take a look at this. Go live. And let's manage this one. Yes. No, it's not right. Let it not run like this. Yeah, okay. 2 people are there. One person in YouTube, right? In one concurrent view. And I don't understand why. This device. So HDMI, USB. No, not that one. No problem. Okay, let's go ahead with okay สุภาวิทย์มาแล้วนะครับปานธรนะครับไม่รู้ว่าที่ซูมจะมีใครเข้าหรือไม่นะครับโอเคyeah, that's the whole thing right okay ปานธรพิมพ์มานะครับสุภาวิทย์ปานธรพิมพ์มาทั้ง2ที่เลยนะครับโอเคthen let's start our session because we are 10 minutes late already ซูมจะมีใครไหมเอ่ยผมพยายามชำเลืองมองดูเลยนะครับคนละเครื่องกันครับเพราะว่าเครื่องนี้มันก็ไม่เตือนครับ okay we have arrived at the story about okay we finished the procedure okay here liquid density okay of course water is a kind of it's an example of liquid right water has 3 phases ice as the solid steam as the gas right and yeah มีภาษิตพิมพ์มาที่อันนี้ด้วยนะ จอด้วยครับ Okay. The first one is liquid form. Okay. This is the common form of water. Okay. Liquid phase. Okay. Water is not the only one type of liquid. There are several types of liquid, for example, olive oil, vegetable oil, wine, colored water, and dish soap, maple syrup, and so on. Right? In yeah, 1, 2, 3, 4. Okay, when you combine all these 6 types of liquid into a single container, okay, they are not gonna be mixed together. Okay, they will not completely combine together. They will stay in a different layer like this. Okay, they have their own layer in what else? The you may ask what is the reason why they don't try to be mixed together. All right. Yeah, they don't stay together because they have their own value for the density, and one of that's the density is the main key feature to differentiate them. Which one is gonna stay lower, which one is gonna stay on top. Okay, density is the feature. Okay, the key property to this phenomenon. Okay, let's get into the detail of density. You may have ever heard this one before, right? Since you were in Matthew 1, 2, 3, 4, 5, and so on. Okay, for Matthew 6, we would say again, density is the measure of the amount of matter per unit volume. That's the broad view of density. Okay, amount of matter per size. Okay, and that size is in 3D. The 3D size of any object is called volume, right? Density is the mass. Okay, amount of matter is the mass. Okay, the mass divided by the volume of a substance. We use the Greek letter rho, or maybe you can also use the letter D. Okay, for the density. If the mass m of the material has the volume v, its density is given by rho equal to m divided by v, right? M is the mass, v is the volume, right? Unit of any quantity in physics is also important. Let's talk about that. Of course, the mass, the first variable at the numerator, has the unit of kilogram, right? Kilogram in the SI system. Volume, of course, is the product of 3 quantities: the height, the width, and the length, right? Width, length, height. So 3 times of meter is gonna be cubic meter. So we have the unit of density as kilogram per cubic meter. All right, let's go further. The density depends on it's not fixed. Okay, it depends on temperature and pressure. Okay, especially for the gas. If the volume changes, its density is also changes. If the temperature changes, its density also changes. If the pressure changes, its density also changes. Okay, that's there are so many factors that the density is gonna change. It also depends on the way atoms stack together in solids. Okay, even the temperature are the same, the pressure the same, we may have different density values for different for the same type of atom. Okay, or the same kind of elements. For example, the carbon. Okay, We will talk about it later. Example is here. Some elements may have many allotropes or forms. Okay, it depends on how your atoms are arranged. Okay, how your atom arranged. Okay. For example, let's talk about carbon elements. Okay, the element of carbon. We have graphite as one example of carbon. Diamond is also a carbon, but as you know, graphite and diamond have completely different properties. Okay, graphite is cheap. Okay, graphite is not expensive. Diamond is extremely expensive. Okay, but both are the solid form of pure carbon. Okay, and they have different densities. Graphite and diamond have different densities and also other properties. Okay, if you study physics, if you go further, you're gonna see different or other property aspect of the carbon or the graphite of any element too, right? But we will not talk about that. Okay, we will go straight with the course description of SCI33206 only. Gases are less dense than liquids. Okay, that's in the general case, but it's not 100% true. True. Okay. Gases are less dense than liquids. Okay, it has less density than the liquids, and of course, it should be less dense than the solid. Okay, I would say this sentence is in the general case. Okay, is valid for the general case. It's not true for every cases. Because there are also some exceptions. For example, ice and solid. มีใครจะเข้าที่ซูมไหมผมพยายามมองไม่เห็นนะครับ For example, ice. What do you think? ถามภาษาไทยก็ได้ น้ำแข็งกับน้ำใครความหนาแน่นมากกว่ากัน น้ำแข็งกับน้ำใครความหนาแน่นมากกว่ากันครับมีคนตอบได้ไหมน้ำแข็งกับน้ำใครหนาแน่นมากกว่ากันAny idea about it มีใครตอบได้ไหมน้ำแข็งกับน้ำใครความหนาแน่นมากกว่ากัน All right. From what the scientists has kept, they found that ice is less dense than the water. Okay, they have less density than the liquid form of water, which is the water. Okay, that's the thing. Okay, we have to accept. It's not. As I told you, it's not true at all that the density, the solid form may have more density than the liquid form. Okay, a few gases can have more density than liquids. For example, water is lighter than tungsten fluoride hexafluoride gas มีใครเคยได้ยินอันนี้ไหมครับทังเซนเฮกซาฟลูอไรด์ครับมีใครเคยได้ยินไหมทังเซนเฮกซาฟลูอไรด์ Has anyone ever heard about that มีไหม No Okay yeah it's a special kind of gas and yeah we won't get into the detail, but I just point out a few examples of the exception. Water and tungsten hexafluoride, which is a kind of gas, right? Okay, yeah. Generally speaking, gases are less dense than liquids, and liquid is less dense than solid. Okay. Hydrogen is we are talking about the density, okay, and we will talk about pressure later. Hydrogen is the lightest or least dense element on the periodic table. Okay, is the smallest, lightest element. The densest material found on Earth. Okay, we are talking about the substance on Earth only, and it's called metal osmium. Okay, the metal osmium, and this material has the density of extreme value, which is 22,500. Okay, 22,500 kilogram per cubic meter ใครจะเข้าไหมครับที่ซูมนะผมพยายามชำเลืองครับ and what else that's the stuff on Earth. Okay, let's talk about the stuff outside our world, outside our Earth. The density of some other planets, for example, white dwarf star is on the order of 10 raised to 10, okay, with a power of 10, which is extremely high. Okay, and the most dense object, as the scientist has found, I'm not sure whether in the future maybe they have found something, they can find something which is more amazing. Neutron star, I don't know why the density of neutron star is on the order of 10 raised to 18. Okay, it's even greater than this one. Okay, it's very, very dense. I don't know which situation that planet is gonna be full of only neutrons. Okay, let's take a look at the table. This is the density table from the book number 1 of some common substances. Ice, okay, which is in the solid. Okay, this column is given for the solid form, solid phase of several materials, and this column is given for is provided for the liquid phase of several materials. Let's take a look at the solid form. Ice is 0.917. Okay, it's less than 1. You can see here. Let's compare it to the water density. Water density is 1,000 kilogram per cubic meter, right? But the ice is less dense than the liquid form, unfortunately. Okay, the aluminum, okay, it's the light metal, right? It's 2.7 times 10 raised to 3. And now we reach the heavy metal like iron 7.86 and copper 8.92 thousand. Okay, silver 10,500 kilogram per cubic meter, and lead is 11.3. Gold is even double. Okay, double the value by most heavy metal. That's why it's quite rare. Okay, it has a spatial structure. It's quite strong compared to the rare and so on. 19.3 thousand, 19,300, and platinum is even rarer than other elements. It's 21.4 thousand. Uranium, okay, which is quite interesting for at the end of this subject. Uranium is of the density 18. Okay, it has density 18.7 thousand kilogram per cubic meter. Okay, everything here is on the 1000 order, and also here for some liquids, water 1000, glycerine is 1.6, has 1.26 thousand. Ethyl alcohol is somehow ethyl alcohol starts to be under 1806 only. Benzene, okay, which is the fuel to our automotive industry, 879 kilogram per cubic meter. And mercury, unfortunately, it has almost the same density to several heavy metals here. Now mercury is an exceptional case of fluid, of liquid, right? And now we reach the gas phases. Air, right? It has 1.29, okay, not 1000 anymore, okay, and because this is the gas phase. Oxygen has the density of 1.43. Hydrogen is even less than number 1, okay, it's only 0.0899, okay, or it's approximately 0.1 kilogram per cubic meter, and helium is somehow less than that. It's heavier, it's almost to 0.2 kilogram per cubic meter. Okay, yeah. What else? The gas, right? The gas phase. This is the same density table, but it's taken from the book number 2, gas, okay, 1.2, liquid form, benzene, ethanol, water, seawater. Seawater is more dense than the pure water, okay, it's 1.03, okay, it's greater than 1.00. Blood is 1.06, which is greater than water. Crystalline is 1.26 thousand. Okay, it is a kind of solid. And ice, yeah, as we know, it's less dense than the pure water in the liquid form. And now we reach the solid form. Solid form, concrete, for example, is not metal, but it's a basic structure you can see in our building. Concrete is 2000 kilogram per cubic meter, is double the value of air, and aluminum is 0.7. Okay, it's a little bit heavier than concrete, and iron or steel is almost 10,000. Brass is also almost 10,000. Copper too. Apart from that, silver, lead, gold are considered as a very heavy metal, and platinum, which is the good material for superconductor, its density is 21.4. Mercury is not solid, but it has really large value for density, is 13.6 thousand. And the exceptional 2 cases, right? White dwarf star, 10 with the power of 10 kilogram. Oh, it's extremely heavy. Neutron star, oh my god, beyond anything. Yeah, 10 with the power of 18. Now we reach the first example about the calculation of the density. Well, what is that here? Find the mass of the air and the weight in a living room like this. Okay, and the dimension of this room. Okay, let's say it's a typical cubic room. I'm not sure whether you build. Usually in the house we would have cubic room, right? Yeah, we would have the width of 5 meter of length 4 meter and of the height 3 meter, and that's the room. And the second question is, what would be the mass and the weight of an equal volume for water case? Okay. Yeah, here we have the sketch of the cubic room, and let's get into the detail for the first first question. Yeah, this one we have we need to determine mass of the air, right? What is that? And the weight of the air, and what is that, right? And yeah, we will talk about it. Okay, mass of air could be found from the basic definition of the density, right? Rho is mass per volume. Mass of what? Mass of air. V of what? V of room. Okay, and yeah, if you go further, what is the mass of the air? You want to determine mass of the air, right? Mass of the air will be rho of air times V room. Okay, the volume of that room. And the rho of the air is the density, right? Density of the air is, as we know before, it's 1.2 kilogram only. Okay, it's not much. 1.2 times the volume of the room, which is here, right? 3 times 4 times 5, and we will get 1.2 times 60, and it's 72, right? Kilogram. 72 kilogram for the mass of the air in this room. Okay, it's almost 100, right? So the weight of the air could be found from the product between the mass of the air times the gravitational acceleration on Earth. We get 72 kilogram times 9.8, and after you put it into the calculator, you will get 705.6. It's Newton, right? Because it is a kind of force. All right. Yeah. The next thing is to compute the mass of the water if we fill that room by water. The mass of water in that room, what is that? And the weight of water if we fill that water with if we fill that room with water. Yeah, what's that? And the mass of water again could be found from rho and V, right? Mass of water is gonna be found from rho of water times volume of that room, because we will fill that room by water, and rho water is 1000, right? And the volume of this room, as we have calculated before, it is equal to 60, right? Yeah, 60. Yeah, okay. Volume of that room is 60. So we have 60 cubic meter, and yeah, when we make the multiplication, we get 10 times 6 times 10 with the power of 4 kilogram, right? And the weight of this water, right, is the next thing. Weight of the water could be found from the mass of water times G, right? So mass of water is 6 times 10 raised to 4, and G is 9.8. You can also use 9.81, okay, or number 10, it's up to you. 9.8, and after you pass it through the calculator, you will get 5880, right? 58800, and the unit for the weight, which is a kind of force, is Newton, right? So we get 4 answer to this problem already, right? These one. Okay. Now let's move to the next topic. 11:50, right? 11:30. I should leave you. Okay, the pressure is the next term in this story. Okay, we didn't start the fluid pressure and buoyant force yet, but we will talk about density and pressure first, because those are two main fundamental things, right? We need to see. Okay, the first one, pressure, right? Pressure is the force per unit area, as you have seen before. Actually, this term should be considered in the chapter of gas and heat, right? Heat and gases. Okay, this one is the force perpendicular to that area, right? This one is area, and here is force, perpendicular force, right, to that area. And if you divide this term by this one, you're gonna have pressure. Okay, pressure is F perpendicular divided by A, which is the area. And the SI unit of the pressure is in Newton per square meter, right? Here, Newton per meter square. And yeah, the unit is given in a special name called Pascal too, right? We may have ever heard this unit as Pascal. And the atmosphere actually is the layers of air wrapped around the Earth. The air has a weight, right? Because in the air we have also particle of air, and a mass of one molecule of air would have the attractive force to the Earth, right? The atmosphere, the air has a weight and pressure against everything it touches, and is known as gravitational force or gravity. The gravity pulls the air downward to the Earth's surface, and we use a device to measure the pressure, and that one is called barometer, right? Barometer is a measuring device that is used to measure the pressure. It's an instrument used to measure atmospheric pressure. It is also called biometric pressure. Okay, if we get atmospheric pressure from the barometer, it's called barometric pressure. This pressure varies with weather changes and with elevation too, right? Okay, it changes with weather and elevation. Okay, if you cannot imagine, let's take a look at this figure. Okay, if you we have the Earth, right? The Earth has the shape of not perfect sphere. Okay, it doesn't have the shape of perfect sphere, but rather the, I don't know, It's spheroid. Okay, we have already seen the actual shape of the Earth, which is called a spheroid, right? And yeah, it's spheroid. All right. It's spheroid because when the Earth rotates around its vertical axis, there is centrifugal force on the sea water, right? The ocean water, and it's gonna bend a little bit out of the skin of the Earth, and that causes the spheroid shape for the Earth. Okay, if the Earth doesn't rotate, okay, we would have perfect sphere. Okay, atmospheric pressure is the weight of the air in a column above our level. Okay, this is our level, and here is the pressure, that is the force acting onto a certain area. Okay, that's force. And the measurement or the instrument that we use to measure is called a barometer. And Aneroid Barometer is the type of is the famous type of a popular type of barometer. It uses the seal box, okay, to have some effect about the air when this box is gonna expand or reduce its size or contracts, okay, with the pressure. And after this expansion and contraction, this instrument is gonna pull or push a spring to move a pointer up and down, okay, to move this needle up and down. Okay, they may use the value of this of the result on this on the Anaerobic barometer scale to measure how the weather is gonna be. For example, if we have very large value for the pressure, we would say that would be the sunny day. If we have a middle value of the pressure, we are gonna say today we are gonna have many clouds. Okay, and if we got a really low value for the pressure, we're gonna say it's gonna be raining. Okay, today is gonna be rainy. Okay, and yeah, that's the ancient way in pressure measurement. Nowadays, every device is transformed into digital age, right? Into digital format. And without any exception, the barometer has been transformed into digital version like this. Okay, we have several digits like this, and it can display complex atmospheric data more accurately and quickly than ever before. Okay, the measurement is even more precise than the former generation of barometer, and it just gives you quick version to be understandable. Okay, for example, you can't just realize the value of the pressure in terms of megapascal or even in other unit. All right. Atmospheric pressure is denoted by PATM. And what is that? It is the pressure of the Earth atmosphere. Okay, atmosphere. The pressure of the air at the sea level in which we live, and that's the meaning of PATM. Okay, ATM doesn't stand for automatic teller machine. Okay, the machine where you withdraw your money. It's not the case. Okay, ATM here is atmospheric pressure. Okay, when it has the subscript for it locates at the subscript position for the pressure is going to be atmospheric pressure. The average atmospheric pressure at the sea level and and measured at the temperature of 15 degrees Celsius is used there as the unit of pressure, and we call it ATM, okay, atmosphere, and it's given by this relation. Okay, if you work in several societies in science, okay, different people may want the same quantity in different scale, okay, because their quantity may not be small or middle or large in different area. So they would prefer to have their own units. Okay, it depends on the society you work inside. But in a typical way, we are gonna be easily understandable about the pressure in SI's unit, like Newton per square meter, or abbreviated by Pascal here. And one more pressure that is widely used is called bar. Okay, one atmospheric pressure is equal to 1.01325 times 10 to 5. That's the complete version in the SI system. But if you talk about the people not in the scientific laboratory, you would see that some people, you may hear that some people may say the pressure in terms of bar. This value is equivalent to 1.01325 bar, and in millibar, okay, you know milli is 10 with the power of -3, right? So it's in a tinier scale, it's gonna be a smaller scale, it's gonna be 1015.25 millibar. Okay, and if you work in the English-speaking countries like United Kingdom, United States, and New Zealand, Australia, and so on, they're gonna use the British measurement system and also the unit 2. And the pressure of one atmosphere is equivalent to 14.7, okay, almost 7 power per square inch. Okay, P stands for power, H is square, and I is inch, right? It's power per square inch. Okay, is it understandable? And if you want to measure it with respect to the mercury height, okay, mercury height, Hc is mercury, right? We would say 1 atmosphere is equal to 760 millimeter mercury. And if you, millimeter is the unit for everywhere, right? Everywhere in the world. But if you work in an English-speaking country, they're gonna not use millimeter. They would rather use inches instead of millimeter. And in terms of inches mercury, we're gonna have 1 atmosphere equal to almost 30, 29.9212, okay, inches mercury. Where Pascal is used worldwide, millibar or hectopascal is used by meteorologists, okay, the people working on weather prediction, weather forecast, all right? And inches mercury is used in the United States, for example. The Biometric Formula is given by this one, okay? Once you have this expression and you want to observe the pressure above the sea level, okay, above the ground level on Earth or the surface of the Earth, and if you are higher, like if you want to go to Everest mountain in Nepal, or if you are in the airplane, okay, which is quite high above the ground level, you may wanna know what pressure at that moment is. So the pressure at different height could be found from this formula is PATM. Okay, PATM is this value 1.01325 times 10 to the 5. That's the basic value, and yeah, this one has the power. E is exponential, and exponential has the power of minus. If you move this term to the denominator, you're gonna find that if you increase the height, you're gonna have lower pressure. If you increase the temperature, you're gonna have also higher pressure, right? Because temperature appear as the denominator, okay, of the exponent of this exponential function. Okay, K is the Boltzmann constant, which is equal to ideal gas constant divided by 2 by the Avogadro number, and T is the temperature in Kelvin. If you stay in a hot tube area, you would have also a higher pressure. Okay, because T is at the denominator division by greater exponent of the exponential is gonna reduce this one. All right. Now we arrive at the calculation of something, right? Okay. Before that, let me capture the screen so that we would agree what's going on. Có đấyยังไม่ได้พิมพ์ชื่อนะครับก็พิมพ์เสียงนะครับ All right. Yeah, here, in this example, in the room described in the previous example, which is this one. Okay, this room. They want to know what is the total force on the floor due to the air above the surface of the air pressure. If the air pressure is 1 atm. All right. Yeah. So where is the floor? This one is the box. Is the cubic, which represents the room, right? Yeah. And where is the floor? The floor is like this. The floor is right here. Okay. And total force on the floor, right? We're gonna have force pointing downward perpendicular to the ground here, right? And what they want to know is what is F on the floor, right? F perpendicular, F with the subscript of perpendicular symbol. Yeah, as we know, the basic term, basic relation หมดนะครับไต่ปากกานะครับ P equal F perpendicular by A, right? A is the floor, A floor, right? So if you want to find the perpendicular force, it would be the product between P and A. P is the pressure at the atmospheric times A, the area of the floor. All right, the area of the floor like that in F perpendicular. What is that? Okay, F perpendicular will be the product between pressure at the ATM at ATM, right, atmosphere. It is 1.01325 if I can remember properly. 0.01325 times 10 raised to 5. The unit is Pascal, of course. And the area of the floor, right? The floor has the length of 3 and 4, right? With 5 and length 4, so 5 times 4. And it should be 20, right? To blah, 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 times 10 raised to 6, right? Yeah, it's equal to 2.065 times 10 raised to 6. Okay, and the unit is in Newton, like this. Okay, I hope it's not too difficult. Yeah, that's the thing you may see from this one. ไม่รู้ว่าเวลาถ่ายกล้องข้างบนแล้วมันสะท้อนหรือเปล่าเดี๋ยวผมปิดไฟดูลองปิดไฟดูครับถ้าคนที่ดูที่ถ่ายจากกล้องจอบน iPad ครับ Alright, I hope that there is no light reflection and you could see well, right? นะเดี๋ยวขอเช็คดูที่เครื่องนี้this one. This one. Okay, at the stream lab one watching now. Okay, I'm not sure you can see me well. Okay, it's a little bit darker. But there is no reflection at all. นะครับสำหรับคนที่ดูอยู่ตรงนี้นะครับก็น่าจะเห็นดีขึ้นนะเพราะผมปิดไฟนะครับโอเคyeah the perpendicular force is known as this value, right? We arrive at the next example, and this example talk about something more complicated. In figure 36, okay, it's taken from the book number 1. We have liquid fluid in a gas like this, okay, in a gas like this, we have something like this, and the water is filled in this glass. They consider a cylinder piece of water in this volume, and when the lid of this glass is open, okay, there should be also the pressure, which is the force pointing onto the upper lid of this cylinder, right? And of course, the inside this cylinder there is water, right? And the water is gonna bring us the weight, okay? And the weight is denoted by vector W here. And assume that this cylinder has the radius as the letter R. And in the lower lid, there would be force pointing upward, okay, to support this so that this water doesn't go down, okay. It stay in the equilibrium state, so there is no movement of water at all, so the force pointing upward should be equal to the summation of these downward forces, okay. Upward force is caused by the pressure of water and must equal the weight plus the downward force, okay. We consider the equilibrium state, okay. If the force is not in balance, okay, this water is gonna move downwards, okay, and you would see it in a different way. All right, yeah. Pressure of the water inside the glass, right? And we alive at there are 3 questions in this example, okay. But these 3 questions are associated are related to each other. Calculate the weight of the cylinder column, okay. We call this one is cylinder column or cylinder can, okay. If you have Coca-Cola can, it's the same thing, okay. And inside the Coca-Cola can there is water filled in, and when this Coca-Cola can doesn't move, okay, Coca-Cola can represent the cylinder, okay. It's supposed to have cylindrical shape, and this Coca-Cola can doesn't move, and the radius of this Coca-Cola can is 1 meter, or we wouldn't have Coca-Cola can of radius 1 meter, right? But assume we have that. All right, and yeah, we assume that we have this Coca-Cola can, and what else? The height of the Coca-Cola can is 40 meter, or it's a giant piece of can. Okay, calculate the force exerted by the air on a disc of radius 1 meter at the water surface. Okay, they want to know if down here, okay, the force which is caused by the air that tries to push the upper lid of the Coca-Cola can, okay, the force due to the air, okay, is not related to the water or liquid at all. Okay, first thing first, we need to know the weight of the cylindrical column of water with the side height 40, latest 1 meter, and the pressure at the depth. We have to, it's 11:50, right? We still have 17 minutes, okay. And the pressure at the depth of 40 meters support the water column. So they want to know the pressure in this area, okay. And the pressure could be found from the force, right? Because we know that pressure is the force divided by the area. Pressure is force per area. So if we know force and area here, we would be able to also to determine the pressure, okay. Please know that these 3 questions are related to each other, and yeah, let's do that. Compute the 3 quantities they want to know. The first thing is the weight of the water inside the cylinder, right? And what is that, right? Of course, weight is mg, right? Weight of water, right? Weight of water. is equal to m, right? M of water in that cylinder, right? M water times gravitational acceleration on Earth, and the weight is mass times g, and what else? The mass. What is mass? G is known, right? We are on Earth, so it's 9.8, right? 9.8 only, and yes, we know G easily, but mass of water, what is that? Let's get into the detail of mass of water. Mass of water in this can, right? So it should be the product from the relation density is mass per volume. If we want to know the mass, it should be the product of density and volume, right? Mass water is density of water times volume. Volume of what? Volume of this shape, which is cylinder. Okay, cylinder, and m water is rho and v, right? Rho water is density of water is 1000, right? 1000 times volume of this cylinder. And what is the expression of cylindrical volume? It should be pi square h, right? The cross-sectional area times the height, and yeah, we have 1000 kilogram per cubic meter for the density. We have pi, and we have radius r of the cylinder, okay, which is 1 meter, so 1 square, and height is 40 meter, right? So we're gonna have here 40, and if you put it into the calculator, you're gonna have 1.23 times 10 raised to 6 Newton, okay, or million Newton, okay. The first thing, okay, weight of the water. Let's get to the second quantity. Second quantity is the force, okay. Force caused by the air on the upper lid. Okay, let's say the cylinder has the upper lid, and yeah, the lid is over here, right? We assume that we have the lower lid and upper lid, right? And here is the upper lid of this can, of this cylinder, right? And we're gonna find the force. What is F in this on this lid? F perpendicular. What is that, right? And what is that, right? So F perpendicular from the pressure relation, P is F perpendicular by A, right? So F perpendicular should be the product of pressure. Pressure of what? At this level, we are on Earth, at the ground level, at the sea level. So we would have PATM, okay, the normal pressure, atmospheric pressure, PATM, times what? Times the pressure at the upper lid. A of what? A of the disk, okay, of the disk. And yeah, what is that? This one is 1.01325 times 10 raised to 5 Pascal, right? In yes, it should be the area of the disk should be the same here, right? Because it's cylinder, It's pi r square h. All right, pi r square h. And yes, after you substitute everything, right? 325 times 10 to the power 5 pi with 1 square and 40. After you put this into the calculator, you're gonna have F perpendicular, right? It's F caused by the air. It's 3.18 times 10 with the power 5. Unit of force is of course Newton. Right, we finished the second quantity. Let's talk about the third quantity. They want to know pressure at this level. Pressure at this level would be equal to the force times the area, right? F up times the area. But what is the expression of F up? Of course, this is the can, this is the cylinder. There is two force. This is P air or P perpendicular. There is the weight of the mass pointing downward, and this is the weight W, and there should be also the force pointing up at the lower lid, right? This is F up. Okay. P air is this one. Okay. Sorry. F air. This one. F air is pointing downward like that. And from the first law by Newton, the first Newton's law, we would have when everything stay in equilibrium state, sigma F remains 0. And let's say if the term pointing up is gonna be plus, okay, pointing up is plus, so everything that points in the opposite way is gonna be considered to be negative value. So F air is gonna be negative F air in this case, because plus is pointing upward, right? Plus mean pointing upward. And W is gonna be negative W, right? W water. Okay, W water. And pointing up is plus F up. Remains 0, right? So F up is don't know. We want to find F up is unknown. Right? We're gonna explain everything in terms of F up. So we move these two terms to the right hand side of this equation, and F up will be F air plus W water, right? So what is F air? F air is what we have found recently, which is P perpendicular. It's 3.18 times 10 raised to 5 and plus W water 1.23. Okay, 1.23 times 10 with the power of 6. Okay, and that's it. We're gonna leave it like that. F up. You don't have to put it into the calculator because let's talk about the pressure at this level. Pressure at this level could be found from the basic term of the pressure definition. Pressure is F up by area of the disk again, right? And you know F up is this term, right? Two terms here, summation, 3.18 times 10 with the power of 5 plus 1.23 10 raised to 6 divided by the area, which is pi r square, right? Pi r is number 1, pi r square. Only there is no h, right? So if you leave this into the calculator, you're gonna have it like 4.9 3325 times 10 to the power of 5, and unit is Pascal, like that, and that's the answer to this question. Okay, the pressure at this level is gonna be this value. Okay, 4.93325. Okay, it depends on how large the this is. Okay, depends on how depth or how deep we want to observe, right? It depends also on the pressure of the air, and if we stay at the sea level, it's atmospheric pressure. Okay, now we complete this example, and let's talk about fluid pressure, and we're gonna start beyond force later. Fluid would flow from the higher pressure region to the lower region, right? That's the main thing you may have ever heard. When fluid is at rest in a container, all portion of the fluid must be in static equilibrium, at rest with respect to the observer. Okay, it has no movement when the observer look at this, and all the points at the same depth must be at the same pressure. Okay, here you would see that when there is no water flow and so on, at the same level you would have the same pressure. Okay, whether it's quite close to the wall of the glass or it's in the center. Okay, in the same level would have the same value for the pressure. Okay, when the fluid is at least in a container, or portion of the fluid might be static equilibrium, less with respect to the observer, or point and the same depth might have the same pressure. Okay, in for example, in this one, if there is no movement of water at all in the static fluid, the force F1 must be equal to the force F2. Okay, but it's in the opposite direction, right? And this one we consider อันนี้ไฟล์ผมเพิ่งแก้ให้เลยนะครับสอนห้อง6.4มาพิมพ์ผิดนะครับ Okay, now we consider the pressure difference, okay, from one point to another point, as the shaded fluid is neither sinking or rising. Okay, when the water in this portion doesn't move at all, it doesn't go up or it doesn't go down, it stays like this. Okay, constantly. With this condition, we would have force exerted on the upper lid, which is known as P1A, right? P1 is the pressure at the level Y1, and area of this one would be considered as the variable A. And if you want to find F is PA, right? P1A at this level. And if you go deeper to another lid, another side of this cylinder, and the length here is Y2. Okay, the depth is Y2, and if you want to measure it, and you would see that there is the weight of this water as same as the previous example. Okay, and you have pressure pointing up, right? And the F here is P2A. Okay, P2A is the product between the pressure at this level Y2 times the area of at this level. Okay, as the shaded fluid is neither sinking or rising, the net force on it must equal 0. Okay, the total force P1 plus A plus mg should be equal to P2A. That's the figure from book number 1. For the book number 2, you would have PA here, and P0 is the pressure at this level under the box, and in this box, okay, it doesn't matter if you use the cylindrical shape or rectangular shape, okay, or the cubic shape here. P0 is the pressure under the lower lid, okay, and A is the area of this cross section. And force due to the pressure P on top of the surface, weight of the volume of the element. P0A is the pressure, the force at the lower lid. And if you form up, P0 pointing up should be 0, PA pointing down should be negative. No, sorry. P0A pointing up should be positive, PA pointing down should be negative. Same as W pointing down should be negative too, right? In yeah. We are gonna analyze 31ละได้เวลาแล้วครับเดี๋ยวขอจบตรงนี้นิดนึงนะครับสมการเนี้ยแล้วก็เดี๋ยวก็จะว่ากันละเลิกแล้วครับ Okay, let's examine the fluid contained within the volume indicated by the darker area in figure 38 and figure 39 are this one 38 and 39. Okay, in these two figures, A is the cross-sectional area, right? And that extends from position y1 to y2 below the surface of the circuit of the liquid. Three external forces acting on this volume of fluid. Okay, the first one is P1A, the second one is mg, which is the weight of this volume, and P2A is the pointing up force. Okay, try to lift this one up. And that was what P1A, the force of gravity, mg, the upward force, P2A. And from the first law by Newton, sigma F remains 0. We have minus P1A, right? P1A is pointing down is negative. P2A pointing up is positive. Minus mg, which is the weight of this water, pointing down should be also negative here. Okay, and the mass of this volume of this piece of water is going to be found by rho times V, and V is the cross-sectional area times the depth delta Y. Delta Y is Y1 minus Y2, so we would have finally minus PA plus P2A minus rho A. Okay, we can cancel A from this equation. A is the same, and we would have minus P1A plus P2 minus rho Y1 minus Y2 times Z. And if you want to find P2, you just move the negative term to the right hand side. You have here P2 equal P1 plus rho G Y1 minus Y2. Okay, we move G to the front already. Okay, fluid density is rho right here at a given level pressure P equal to external pressure PATM plus the pressure due to the weight of that overlying liquid rho GH. Okay, and P0 is right now equal to PATM. Okay, the upper pressure times rho GH. Rho is the density of that fluid. G is the gravitational acceleration on Earth. H is the height. And yeah, we would have that result in this expression. We have P equal P0 plus rho GH. What is P0? If we leave this glass on Earth at the sea level, the P0 here should be PATM. So which is it is 1.01325 times 10 to the power 5 Pascal. Okay, and that's it for today's lecture. And if you have any question, just let me know. Okay, if you have any question ถ้ามีคำถามครับถามได้นะครับ if you don't have anything, then we are gonna leave this lecture. Okay, we have to finish the lecture right now. Wellington is the last person, right? In let me check again here. Let me check whether I send you the last version or not. In this room, Kitiwat is the last person. All right, Kitiwat is the last person, and this one, Wellington number 19 เขียนหมายเลขให้ถูกกันด้วยนะครับห้อง605นะครับมีทีรุตขอออกนะครับทีรุตPanaton is only the single person in that Zoom to share YouTube channel. Okay, nothing more, right? The homework for today's lecture is gonna be any problem related to pressure and density โอเคปัญหาเกี่ยวกับความหนาแน่นหรือว่า pressure ก็ได้นะครับ1ข้อนะครับ and now we're gonna quit this lecture right now see you on Wednesday บ๊ายบายครับสวัสดีครับ See you on Wednesday